Okay, hello and welcome. Today I'm going to be talking to you guys about muscular dystrophy, what causes it, what affects it, what happens in the body, and how it's diagnosed and treated. I also touch on how AI is actually becoming a big tool in managing this condition. My goal is just to give you a clear picture of how this disorder develops and why early detection matters. So this is just going to be your outline, what we're going to be talking about: the etiology and genetics, the demographics, the anatomy and affected systems, and the physiology and symptoms, and the diagnosis and the treatment, and how AI is affecting it. So we're going to begin with the etiology. Muscular dystrophy is a group of genetic disorders that causes progressive muscle weakness. The type we hear about the most is Duchenne muscular dystrophy, also known as DMD. DMD happens because of a mutation on the DMD gene, which sits on the X chromosome. This gene is huge which normally tells the body how to make dystrophin, a protein that basically acts like a shock absorber for muscle cells. Because this gene is on the X chromosome, DMD follows an X-linked recessive inheritance pattern, meaning it mainly affects boys. Girls are usually carriers. Without dystrophin, the muscle cell membrane becomes fragile, so muscle cells get damaged easily and start breaking down over time. So now we're going to talk about the demographics. So for the demographics, DMD occurs in about 1 in every 5,000 live male births worldwide. If we look at all types of dystrophy, about 1 to 6 or 3.8 people per 10,000 in the US are affected. Something important is that around 30% of cases happen spontaneously, meaning that there is no family history. The mutation just develops over time. So now we're going to talk about the anatomy and the primary systems affected. Even though we think of MD as a strictly muscle disease, it affects way more than just the arms and legs. The biggest systems involved are the skeletal muscle, the cardiac muscle, and the respiratory system. In the skeletal muscle, this is where we see the main weakness and the degeneration. In the cardiac muscle, patients develop cardiomyopathy because their heart relies on dystrophin. The respiratory system, the diaphragm gets weaker, and this causes breathing difficulties later on. Now we're going to go over the physiologies and then what symptoms to look out for. So here's what's happening inside the cells. In healthy muscles, dystrophin keeps the muscle cell membrane stable. Without it, the membrane becomes fragile and tears during normal movement. This lets calcium flood into the cell, and calcium overload eventually kills the muscle fiber. Now we're going to go over the symptoms and what to look out for. Symptoms usually show up early. Kids may walk later, fall a lot, or have trouble climbing stairs. One classic sign is the Gower sign, which is right there, where a child uses their hands to push up their legs when standing because their hips and their thigh muscles are so weak. As this disease progresses, most patients lose the ability to walk in their early teens. Heart and respiratory complications develop later, and those are often what determines the longer outcomes. Now we're going to talk about diagnosis and treatment pathways. So diagnosing MD usually starts with a simple blood test. High creatine kinase levels indicate muscle damage. Genetic testing confirms the actual mutation, and in most cases, this is enough to diagnose DMD. So now the muscle biopsies are used less often than before. There's currently no cure, but there are a few important treatments, which include corticosteroids like prednisone or delphisocort. Exon skipping therapies are really exciting. These help the body skip over the mutated part of the gene, so it can make a shorter but functional dystrophin protein. And then there's supportive care like PT and OT, heart medications, and respiratory support as the disease progresses. So now we're going to discuss the roles of AI in DMD. So AI is actually becoming a big tool in DMD research and care. It can scan huge medical databases to identify potential medications more quickly, which is called drug repurposing. It can predict things like when a patient may lose the ability to walk or when heart problems might develop. And AI imaging tools can analyze muscles, MRIs in really precise ways to measure how fast the disease is progressing. So AI is making care more personalized and giving researchers a new way to find treatments faster. So overall, muscular dystrophy is a genetic disorder with major impacts on the muscle, cardiac, and respiratory system. We still don't have a cure, but modern therapies, especially genetic treatments and AI tools, are helping improve lifespan, mobility, and quality of life for many patients. Thank you for listening, and let me know if you have any questions. And then here's my reference page. Thank you.